Today, we're going to discuss about the arc length. So start first with the definition. So if f prime is continuous on interval AB, then the length or arc length of the curve y equals f of x from the point A is equal to A comma f of A to the point B equals B comma f of B is the value of the integral. So let L be the arc length or just length is equal to the integral of the square root of 1 plus the square of the derivative of f of x dx from A to B, or that is equal to the integral of the square root of 1 plus the square of dy over dx. Okay, so following that formula, so let us try to solve some exercises. So let's start first with number 1. Define the length of the curve shown below. Y equals 4 square root of 2 over 3 of x to the power of 3 halves minus 1 with the interval from 0 to 1. So this is now the graph for that problem. So first of all, we're going to take the derivative of y. So we have y is equal to 4 square root of 2 over 3 of x to the power of 3 halves minus 1. So taking the derivative of that, or just equal to f prime of x. So that will be now 4 square root of 2 over 3 times 3 halves of x to the power of 1 half. So simplifying that further, so 3 is cancelled and 4 and 2 will be reduced. So we have now 2 square root of 2 of x to the power of 1 half. So this is now our f prime of x, or the derivative of the given function. Then after we know the first derivative, then we are going to take now the square of the derivative, or I can write that one as equal to dy over dx. If I'm going to follow this formula, instead of writing the square of f prime of x, I can also use in terms of the square of dy over dx. So now I have dy over dx, so I will take the square of that. So we have dy over dx, so the square of this. So we are just going to square this one also as 2 square root of 2 of x raised to 1 half. So I will take the power of 2. Then simplifying that one, so we have dy over dx. So the square of this will give us now the answer of 8x. Okay, so after that, we can now write the formula. We know that the interval is from 0 to 1, so we can find now the length. So we have the length now is equal to the integral of the square root of 1 plus dy over dx of the square of this of dx. Then the interval is from 0 to 1. So by substituting the value of dy over dx, so we can write now the square root of 1 plus, so the square of dy over dx is equal to 8x of dx, then from 0 to 1. So taking the integration for that, we are going to use the substitution method. So I will let u is equal to 1 plus 8x, and the derivative of u is du is equal to 8 dx. So I have dx here, so therefore I will define dx. So we have a coefficient factor of 1 over 8, or you can write now du over 8 is equal to dx. So writing the coefficient factor outside the integrand, so I can write now 1/8. So the integral of this is equal to, we have u raised to 1 half of dx. Okay, and then taking the integration of that, we have 1/8 times, we have u to the power of 3 halves over 3 halves, or I can write here as 2/3. And this will be evaluated from 0 to 1. So simplifying it further, this will become 1 over, this one 2 over 8 is 4, so 4 times 3 is 12. So we have now 1 over 12 of u, with our u now is 1 plus 8x. So we have 1 plus 8x to the power of 3 halves, and this will be evaluated from 0 to 1. Okay, so by using the fundamental theorem of calculus, so by evaluating the integrals, so we can now have the answer of 13 over 6. Okay, number 2, find the length of the graph of f of x equals x cubed over 12 plus 1 over x from the intervals of 1 to 4. So the graph is shown on the right side. So first we're going to find the derivative of f of x. So we can write now f of x is equal to x cubed over 12 plus 1 over x. So we take the derivative of that. So that will be now equal to, we have 3 times 1 over 12 of x squared plus the derivative of 1 over x can be equal to negative 1 of x to the power of negative 2. Or this can be written as 3 times 1 over 12 equals 1/4 of x squared. And this will become minus 1 over x squared. Okay, so this is now your f prime of x, but according to the formula, we are going to square the derivative. So squaring the derivative, now we have f prime of x. So squaring this one, so this can be 1/4 of x squared minus 1 over x squared. Quantity of this will be raised to the power of 2. Simplifying that one, so this will give us now 1 over 16 of x raised to 4 minus twice the product of this. I will write 2 times x squared over 4 times 1 over x squared plus the square of the last term now is 1 over x raised to 4. So simplifying it further, so I can write now 1 over 16 of x raised to 4. So x squared is cancelled and 2 over 4 becomes 1/2. So minus 1/2 plus 1 over x raised to 4. So this is now the square of our derivative. Now after that, we can now solve for the length or the arc length. We have L is equal to the integral of the square root of 1 plus the square of the first derivative of dx from 1 to 4. So by substitution, so we can write now the square root of 1 plus 1 over 16 of x raised to 4 minus 1/2 plus 1 over x raised to 4 of dx with the interval from 1 to 4. So by simplification, we have here, so like terms, we have 1 and negative 1/2. So we'll just subtract that 1. It becomes 1/2. So therefore, the integral of 1 over 16 of x raised to 4 plus 1/2 plus 1 over x raised to 4 of dx. So this will be evaluated from 1 to 4. And this radicand is a perfect square trinomial. So therefore, it can be factored in the form of a square of binomial. So I can write that one now as the square root of, we have x squared over 4 plus 1 over x squared. Then the quantity of this will be squared of dx. Then simplifying further, so we can cancel the radical sign and the power of 2. Therefore, we have now the x squared over 4 plus 1 over x squared of dx. Then the intervals from 1 to 4. So I forgot it here, so I put 1 and 4. So then after that, we are now going to integrate. So the integration for this, so we have the length now is equal to, so the integration now will give us, we have x cubed over 12 minus 1 over x. So the integration of 1 over x squared will give us 1 over x. And this will be evaluated from 1 to 4. So by using the fundamental theorem of calculus, so we can have now f of b will give us 64 over 12 minus 1/4. This is your f of b minus your f of a, where a is equal to 1. So we can write now 1 over 12 minus 1. So simplifying that one will give us the answer of 6. So for number 3, we have find the length of the curve y equals 1/2 times e raised to x plus e raised to negative x with the intervals from 0 to 2. So we know that a is 0 and b is 2. So we have to solve first for the derivative. So we have y is equal to 1/2 of e raised to x plus e raised to the negative x. So taking the derivative of that, so I can write now dy over dx. So the derivative of y is dy over dx is equal to 1/2 of e raised to x. Then the second term becomes now minus e raised to negative x. Then we take now the square of the derivative. So the dy over dx. So the square of this. So we can write now, we have the square of 1/2 is 1/4 times the square of the binomial. So I can write now e raised to 2x minus 2 plus e raised to the negative 2x. And then, so since we know now the square of the derivative, so we can solve now for the length, where length is equal to the square integral of the square root of 1 plus the square of dy over dx, and then of dx from the interval of a to b. Our a is 0 and b is 2. So by substitution now, we have the integral of the square root of 1 plus the square of the derivative. We have 1/4 times e raised to 2x minus 2 plus e raised to negative 2x of dx from 0 to 2. So simplifying further the integrand, so it will give us now the integral of the square root of, so simplifying this one, so we have 1/4 of e raised to 2x, so 1/4 of e raised to 2x, and then 1/4 times negative 2 is negative 1/2, plus 1/2 will give us positive 1/2, and then 1/4 times e raised to negative 2x, so I can just write 1 plus 1/4 of e raised to negative 2x of dx from 0 to 2. So by continuation, so we have here, so this integral now will give us the perfect square trinomial whose factor of that will become a square of binomial. So taking the square root of the first term, we have 1/2 of e raised to x plus the square root of the last term, we have 1/2 of e raised to the negative x, and we are going to square this quantity. To check the middle term, so multiply twice the product of these two terms will give you the answer of 1 half. So from the interval of 0 to 2, square root of this. So we have here the integral of the square root of, since the common factor is 1 half, so I will write 1 half times e raised to x plus e raised to the power of negative x and then power of 2 of dx. So the quantity of e raised to x plus e raised to the power of negative x will be raised to the power of 2, and with the interval from 0 to 2. So the radical sign and the power of 2 will be cancelled. So we have now the integral of 1 half times e raised to x plus e raised to the power of negative x of dx from 0 to 2. Now, so we take the integration for that. So we have now 1 half of e raised to x minus e raised to the negative x, and this will be evaluated from 0 to 2. By evaluating this one using the fundamental theorem of calculus, so this will give us now 1 half times e squared minus e to the power of negative 2. Or if you like, it has an approximate value of 3.63, but I prefer to have this rather than this one. Number 4 is find the arc length of the graph. F of x equals 4 times the quantity of x minus 1 to the power of 3 halves between x equals 1 and x equals 2. So first we're going to solve the derivative of f of x. So I will write first f of x equals 4 times the quantity of x minus 1 to the power of 3 halves. So taking the derivative of that, this will become 4 times 3 halves times x minus 1 to the power of 1 half times 1. So no need to write 1. So by simplifying this one, we have 6 times x minus 1 to the power of 1 half. So this is now the first derivative, and we're going to take the power of 2 for the value of the derivative. So I can write now f prime of x, and this will be squared. So therefore, we have squaring this one, this becomes now 36 times x minus 1. So applying the formula of the arc length, or is equal, L now is equal to the integral of the square root of 1 plus the value now of the square of the derivative is 36 times x minus 1 of dx from 1 to 2. So simplifying further the radicand or the integrand, so we have the integral of the square root of 1 plus 36x minus 36 of dx. So simplifying further, we have now the integral of the square root of 36x. 1 minus 36 is 35, so 35 of dx from 1 to 2. So from there, so integrating this one, so I will let u is equal to 36x minus 35. So du becomes now 36 dx, but we only have dx there, therefore we have a coefficient factor of 1 over 36. So we're writing now the given. We have the integral of the square root of, this is now the square root of u times the meaning of dx now will give us now, okay, du over 36, but I will just write here outside the integral of the 1 over 36. So we have now 1 over 36 times the integral of u raised to 1 half of du, or we have now 1 over 36 times u to the power of 3 halves over 3 halves, or take the reciprocal of that times 2/3, and this will be evaluated from 1 to 2. So I forgot this one, 1 to 2. So 1 to 2. So rewriting again the meaning of u. and simplify the coefficients. So we have 2 over 36 is, we have 1 over 18. So 18 times 3. So we have now 1 over 54 times the meaning of u is 36x minus 35 to the power of 3 halves. This will be evaluated from 1 to 2. So by using the fundamental theorem of calculus, this will give us now the value of 37 times the square root of 37 minus 1 all over 54. So that's now the length for this problem. So number 5, find the circumference of a circle with a radius 2 units. So looking at the graph, so we have that the radius is 2 units. So the equation of the circle is x squared plus y squared equals 4. And we solve for y in terms of x. So we can write now plus and minus the square root of 4 minus x squared. So it follows that from x squared plus y squared is equal to 2 squared. So solving for y, so we have y squared is equal to 4 minus x squared. And y now is equal to plus and minus the square root of 4 minus x squared. So that's it. And then we are going to solve for the intervals. So the interval of this, we are just going to assume y to be 0 or the equated one to be 0. So we have 0 is equal to 4 minus x squared. So from here to solve for x or for the interval, we have 0 is equal to 4 minus x squared and then solve for x. So transpose becomes x squared is equal to 4 and x now will be equal to plus and minus 2. Okay, but looking at this one figure only, okay, we have from 0 to 2, or we can also solve using from negative 2 to positive 2. So using the formula, so we have now the circumference of the circle from y equals the square root of 4 minus x squared. So we take the derivative for that. So y prime is equal to 1 half times 4 minus x squared to the power of negative 1 half times the derivative of 4 minus x squared is negative 2x. So simplifying further, we have 2 and the 1 half and negative 2 is negative 1. So I can just write here the negative x over the square root of 4 minus x squared. So this is now the y prime, or we could write dy over dx. And then we're going to square that one. So the square of this will be equal to the square of negative x will be positive. So we have positive x squared over the square of the denominator will give us 4 minus x squared. So using now the formula for the circumference of a circle is equal to 4 times the integral of the square root of 1 plus the meaning of the square of dy over dx, which is now x squared over 4 minus x squared of dx from the interval of 0 to 2. Okay, so 0 to 2 is we're only taking this one from this is now 0 to 2, and we have 4 here because they are 1, 2, 3, 4. So there are 4 quadrants. Simplifying further the integrand, so we have 4 times the integral of the square root of, so simplifying the radicand, it will give us now the square root of 4 over 4 minus x squared of dx evaluated from 0 to 2. So simplifying this further, so square root of 4 is 2. So times 4 outside, it becomes now 8. And the remaining term now we have the integral of dx over the square root of 4 minus x squared. So this integrand looks like familiar to us, and that is we can apply to the arc sign. So therefore, integrating that one, it will give us now 8 times arc sine of x over 2. And this will be evaluated from 0 to 2. Evaluating that one using the fundamental theorem of calculus. So it will give us now the final answer of 4 pi units. This is now for the circumference of a circle. Okay, number 6. An electric cable is hung between two towers that are 200 feet apart, as shown in the figure. So the cable takes the shape of a catenary whose equation is y equals 75 times e raised to x over 150 plus e raised to the negative x over 150 is equal to 150 hyperbolic cosine of x over 150. So find the arc length of the cable between two towers. Okay. So since the given function is y, so we have y equals 75 times e raised to x over 150 plus e raised to the negative x over 150. Okay, taking the derivative of y, so we have now y prime is equal to 1 half times e raised to x over 150 minus e raised to negative x over 150. So taking the square of this derivative, so y prime will be squared. So is the square of the right side will become 1/4 times e raised to x over 75 minus 2 plus e raised to negative x over 75. So what we did is we just square the binomial and square the coefficient. So let us solve first the integrand from y plus the square of the derivative. So will give us now 1/4. We add 1 from the result of the square of the derivative. So it gives us now the answer of 1/4 times e raised to x over 75 plus 2 plus e raised to negative x over 75. And then this one will give us a perfect square trinomial. So we're going to factor this one. So the factor that for this will become the square of binomial. So this will give us now 1 half times e raised to x over 150 plus e raised to negative x over 150. So the square of this. Okay. So using the formula of the arc length, we have L is equal to the integral of the square root of 1 plus the square of the derivative dx from A to B. So the interval is also given from the graph from negative 100 to 100. So this is now the interval from negative 100 to the other tower is another 100. So therefore, we have L is equal to the integral of, so the simplification of the radicand we have now, we have to write now here 1 half times e raised to x over 150 plus e raised to negative x over 150 and the square of this of dx. So the radical sign and this will be cancelled. Okay, so therefore we have L now is equal to the integral of 1 half of e raised to x over 150 plus e raised to the negative x over 150 of dx. This can be evaluated from negative 100 to positive 100. So I forgot here negative 100 of to 100. Now we take the integration for that. So the integration now will have, I'll put 1/2 outside the integral sign. So we have 1/2 the integral of e raised to x over 150 plus e raised to the negative x over 150 of dx. This is now from negative 100 to 100. So integrating that one, it will give us now 75 times the integration of that will give us now e raised to x over 150 minus e raised to the negative of x over 150. This will be evaluated from negative 100 to 100. Evaluating this one, so will give us now the answer of 150 times e raised to 2/3 minus e raised to negative 2/3. So that's the length now, or that is approximately 215 feet. Okay. So dealing with discontinuities in dy over dx. So at a point on the curve where dy over dx fails to exist, then dx over dy may exist. In this case, we may be able to find the curve's length by expressing x as a function of y and applying the following analog of equation number 3. So that equation number 3 is found at slide number 2. So this is our equation number 3. So now we have the formula for the length of x equals g of y is greater than or equal to c, and y is less than or equal to d. If g prime is continuous on the interval c, d, so the length of the curve x equals g of y from a equals g of c, comma c, to b equals g of d, comma d. So therefore, the length now is equal to the integral of the square root of 1 plus the square of dx over dy of dy from c to d. Or it is the integral of the square root of 1 plus the square of the derivative of g of y dy from c to d. So let us try to apply this equation number 4 to find the length. So we have here number 7. Find the length of the curve y equals x over 2 to the power of 2/3 from x equals 0 to x equals 2. This is now the graph for that curve. To solve this, we are going to find first the derivative of the given function. So we have y is equal to x over 2 to the power of 2/3. So we have now dy over dx. So using the power rule, we have now 2/3 times x over 2 to the power of negative 1/3. And the derivative of x over 2 is equal to 1/2. So simplifying this one, so we have 2/3 and 1/2. So I can cancel 2. The remaining coefficient will be 1/3 of x over 2 to the power of negative 1/3. Now, if I'm going to interchange the position of x over 2, then I will also change the sign of the exponent. So therefore, this can be now written as 1/3 of 2 over x to the power of 1/3. Okay, so since it is not defined at x is equal to 0 because 2 over 0 is undefined, so we cannot find the curve's length using the equation number 3. So therefore, we rewrite the equation to express x in terms of y. So from y is equal to x over 2 to the power of 2/3. So we're going to solve for x. To remove the power of 2/3, so therefore we're going to express this one as y to the power of 3/2. is equal to x over 2 to the power of 2 thirds, and this will be raised to the power of 3 halves. So therefore, we have y to the power of 3 halves is equal to x over 2, because 2 thirds times 3 halves equals to 1. That is why we have x over 2. So solving for x now, we have x is equal to 2y to the power of 3 halves. So from here, we are going to find the interval in terms of y, because the given is from x is equal to 0 to x equals 2 if the equation is y is equal to x over 2 to the power of 2 thirds. But now, the equation is x is equal to 2y to the power of 3 halves, then we're going to find the intervals that is equivalent to y. To solve for the intervals in terms of y, then we're going to let x be 0. Therefore, 0 is equal to 2y to the power of 3 halves. So to remove the exponent of 3 halves, I will raise both sides by 2 thirds. So therefore, 0 to the power of 2 thirds still 0. And then we have the remaining, the answer now on the right side will be just equal to 2y. So dividing both sides by 2, therefore y is equal to 0. So one of the interval now is equal to 0, and the other one now is looking at the graph from the curve of y equals x over 2 to the power of 2 thirds. So we know that the interval now is coming from 0 to 1, okay, in this y-axis. Okay, so the other one now will give us from y is equal to 1 coming from this. After knowing the interval, we still need to find the derivative of x equals 2y to the power of 3 halves. So to solve for the derivative of this becomes now dx over dy is equal to 2 times 3 halves of y to the power of 1 half. Okay, so simplifying that, that is now, this will become now 3y to the power of 1 half. So that is now the value of dx over dy. Now, since we solved already the intervals in terms of y, therefore that is now from 0 to 1, so we can now use the formula in equation number 4, wherein length is equal to the integral of the square root of 1 plus dx over dy, the square of this, of dy from C to D. So by substitution, we can now write here the integral of the square root of 1 plus 3y to the power of 1 half, which is actually the meaning of dx over dy, of dy evaluated from 0 to 1. I forgot here, we still need the power of 2. So therefore, this is now the integral of the square root of 1 plus, so the square of 3y to the power of 1 half is equal to 9y of dy from 0 to 1. So evaluating that one, so this is just a continuation. So from L is equal to the integral of the square root of 1 plus 9y of dy from 0 to 1. So evaluating to that, we are going to let u is equal to 1 plus 9y, and du now will give us to 9 dy. So we have dy here, so therefore we have a coefficient factor of 1 over 9. So rewriting now the given, so the length now is equal to 1 over 9, which is coming from the coefficient factor, the integral of u raised to 1 half of du. So integrating that one, we have 1 over 9 times 2 thirds of u to the power of 3 halves, and this will be evaluated from 0 to 1. Okay, so simplifying this further, this can be now 2 over 27, and the meaning of u is 1 plus 9y to the power of 3 halves, evaluated from 0 to 1. So simplifying this, it will give us now the answer of 2 over 27 times 10 square root of 10 minus 1. So that's now the answer for this.